Hey folks, before we get into today's podcast, I wanted to share that QCon London returns April 7th to the 9th, 2025. Learn what's next from world-class leaders pushing the boundaries of modern software. You'll learn actionable insights from senior developers working on real-world projects across multiple domains. Learn more at qconlondon.com. What does it mean to be green in IT? That's the question that begins Chapter 1 in Building Green Software. Today, I'm joined by two of the book's authors. Ann Currie has been a passionate leader in green tech for many years. She's a community co-chair of the Green Software Foundation, as well as lead of the GSF's Green Software Maturity Matrix project. Sara Bergman is a senior software engineer at Microsoft. She's an advocate for green software practices at Microsoft and externally. She's an individual contributor of the Green Software Foundation. Unfortunately, their co-author, Sarah, who was unable to join us today. But Ann and Sara, welcome to the InfoQ podcast.
Thank you very much for having us.
Thank you for having us. Excited to be here.
I guess I should say welcome back, Ann. You've been on before, but it's been 3 or 4 years probably. You talked with Wes and Charles in the past. So welcome back. So let's start with that opening question from your book. What does it mean to be green in IT? Ann, you want to start?
It's an interesting question. What does it mean to be green in IT? The O'Reilly book came out in April and is going well so far. People generally like it. It gives a good overview of what we'll need to do. The good thing about writing a book is you learn a lot about the subject while you're writing the book. Going into the book, so when we started on chapter 1, I think our view of what is green software is software that produced the minimum amount of carbon to operate it. So without dropping any of the functionality, without dropping any of the SLAs, it's produced less carbon. And that usually means it's more efficient, uses fewer servers to do the job, or it runs when the sun's shining or the wind's blowing. So there's more renewable power available. But I think by the end, my thoughts on it had changed quite a lot. And nowadays, I tend to think the green software is software that is optimized to run on renewable power, because that is the power of the future. That is the only way that we're really going to get green in the future. So all of those things, being more efficient, being more able to shift and shape work to when the sun is shining or the wind is blowing, it reduces carbon, but it is what is required to run on renewable power. That's a little bit of a confusing answer. So, Sara, what do you think?
I think it's it explains also what our minds went through when we wrote the book. So that's good. Or I don't know, should people have a closer insight to our minds? I don't know if that would be good or confusing. But anyway, no, I agree with your answer. I do think, because we're on a journey, right? The energy transition, so moving from these fossil fuel, always on energy sources that have dominated the energy sector, well, they're going away slowly and being replaced by renewables. We aren't quite there yet, though. So it still matters. The other things still matters. Energy efficiency matters. It's going to matter less, I dare say, once the energy transition is complete, then this shift in capabilities are going to come out in full swing. I also think hardware efficiency is fascinating. So that means doing more with less. So being very mindful of the carbon debt that lands in your hand when you get a shiny new device. And there are many ways we can do this, and that people are already doing it.
I think the two of you hit on a couple different themes, and maybe we should dive into these and explain what the terms mean. So we talked a little bit about just energy efficiency overall, but also, I think, Sara, you mentioned hardware and hardware efficiency. And there's an aspect of carbon awareness that you discuss in the book. So what are those fundamental principles of green computing?
Well, shall I do efficiency and you do hardware efficiency? And then we'll both talk a little bit about carbon awareness. There are specialist subjects. So carbon efficiency is about producing the same functionality with fewer watts required, which really means with fewer CPU cycles, because CPU is very correlated with energy use in servers. So a more efficient system does the same stuff for you, but uses less power to do it. So that's incredibly useful at times when the sun isn't shining and the wind isn't blowing. When you're running off non-renewables, when you're running off fossil fuels, you want to be using less power to produce the same output. And there are various ways you can do it. You can do it through operational efficiency. So just being a bit cleverer about the way you use systems so they're not, for example, over-provisioned. And you can also do it through code efficiency. So not running 10 lines of code when one would do. That's a much more controversial and difficult subject. We've got a whole chapter on it in the book. But in addition to that, we've got hardware efficiency.
Yes, the hardware is, in case you haven't thought about it, it's a very labor intensive and carbon intensive thing to produce because, right, minerals are mined all over the world, shipped to other places, assembled, sometimes in very energy intensive ways before they land in your hand or in your server hall or in your closet where you keep servers. I don't know. I don't judge. But it's a significant carbon debt, right? And that's already paid. Like once you get it and it's brand new, you've paid the substantial, or like the environment's paid a substantial cost for that to happen. So we want to be mindful of that. One of the best things that we can do is to hold on to it for longer so that we amortize this cost over time and prolong the new additional cost of buying a new shiny thing. And if you are a software person, like I do identify as a software person, it's easy to say, well, that's not my problem. It sounds like a hardware person's problem. And they are certainly aware of it and certainly thinking about it and working on it. But we as software people are not off the hook because the type of software that we run highly impacts the type of hardware that we have. I mean, if you just look at any enterprise software today, you could not run it on a machine that's 30 years old, for example, because they are massively improved. Like, so they kind of lockstep, right? We get better machines, we write more complicated software and so forth, so forth. Also on the client side, and now I'm thinking PCs, smartphones, smart TVs, for example, there we see that actually the manufacturing cost in terms of carbon is much higher than the use time. So it's very, very important to be mindful of that cost. And you can do that in multiple ways. And that's a whole chapter in itself. But I think that's the short dish.
Sometimes that carbon that you have to pay out up front, a lot of the terms in this whole area are very confusing. Sometimes it's called embodied carbon. Sometimes it's called embedded carbon, but it's basically the same. It's like the theoretical amount of carbon that was emitted into the atmosphere when your device was created.
Yeah, and it's basically, I believe it's a borrowed expression. It comes from the building industry. They use the same terminology.
I didn't realize that. That's good. And one of the things that's quite interesting is in the tech industry, when you're talking about consumer devices like phones, it's all embodied carbon. That's a major issue. It's a huge issue with embodied carbon in phones and end user devices. But in data centers, embodied carbon is not the main problem. In data centers, because the hardware in data centers is really well managed compared to how you manage your devices at home. You don't keep them as highly utilized. You don't keep them as long. In data centers, it's mostly about the electricity used to power your servers, how that was generated. That's the biggest cause of carbon emissions into the atmosphere.
So carbon awareness, I think, is the third thing we mentioned that we should maybe dive into. But it sounds so sci-fi whenever I mention it to a like unsuspecting crowd. I'm like, yeah, now we're going to go off the deep end. But it really isn't super complicated. So the thing is, energy can be produced in different ways. We all know that. Most countries don't have one source. They have multiple. So the grid mix varies throughout the day, throughout the year, and whatnot, over the course of years also as the grid evolves. And carbon awareness is adapting to this fluctuality. It's about listening to real time, what energy do I have right now, or listen to forecast and then plan how you operate or what you serve to customers based on that.
Yeah, it's interesting. Almost everybody talks mostly about efficiency, and that's a good place to start. It's usually the easiest place to start. It's not hard for people to just go through and do fairly manual stuff to do with sorting out provisioning and cut their carbon emissions by 50%. That's really not that difficult to do. Carbon awareness is more difficult. It requires you to design your systems, to architect your systems, so you have parts of your system that, particularly CPU-heavy parts of your system, workloads, that can be shifted in time, that can be delayed, so when the sun comes up or when the wind starts blowing again. So in many ways, that's very hard. But in the long term, that is absolutely where all the win is, because power that's generated from photovoltaic cells, from wind farms, if you can use it directly, is going to be 10 times cheaper even than fossil fuels. So the win, if you can find a way to use it, is you will get electricity that's 10 times cheaper. But it's a longer term planning exercise to work out how you're going to produce systems that can shift work, take advantage of that.
So this is what happens with every time I talk about green software. You go into like 17 different aspects that we all need to consider, and it kind of becomes overwhelming. And it's easy for someone to say, well, it's embedded carbon in the iPhone, and so that's clearly not my problem. I'm just an app developer, and so nothing I do makes a difference. Or it's up to the data centers because they're the ones that are actually plugged in, and are they running on fossil fuels or solar? So as the lowly developer or architect, how can you convince those people, no, what you're doing does make a difference?
Oh, well, I mean, that's good because it really does. AWS, Azure, I think, use the same terminology. They talk about it as a shared responsibility model. Even in the clouds where they're putting tons of effort into providing services that, I mean, I know that you hear kind of pros and cons of the cloud, and a big company is not one thing. There's loads of things going on in a big company, but they do want to produce systems that will, in the long run, deliver zero carbon power because they want some of that 10x cheaper electricity too. Thank you very much. So they want to produce systems that will run on that cheap green power. But as developers, you have to use those systems. You have to build your applications to run on those offerings that are effectively green platforms that can provide that. If you don't, if you just lift and shift from your data center, from your on-prem data center, for example, into the cloud, and you just run on a dedicated server, you really don't get that much benefit. You get some benefit, but you don't get that much benefit. And the clouds will never be able to be green based on that. In order to be green, you have to start modernizing. You have to start using those services like spot instances, the right kind of instance type, in order to get the benefit of the investment that they're making, serverless, that kind of thing. Both sides are going to have to step up. And if either side doesn't, you don't end up with a very good solution.
Yeah, and I think at the very least, use your consumer power. Do your research before choosing where you host your software, and continue to use your consumer power to apply necessary pressure on the topics you're interested in. That goes for everything, of course. And don't eat the elephant in one bite. Is that the saying?
Oh yeah, don't try and eat the elephant in one bite. Yeah, that is the saying.
Sorry, the two native English speakers need to correct the Swedish person. I don't even know what the Swedish equivalent would be. Anyway, so don't eat the elephant in one bite. Try to break it down. I think most people who have any piece of software, you know where your inefficiencies are. You know the thing you're doing that's a kind of a little bit stupid, but you're doing it anyways because of reasons. So if you can find, for example, a sustainability argument to motivate doing it, I think you're very, very likely going to be able to find other reasons for doing it as well. Maybe this is also cheaper. Maybe this also makes your service more reliable. Maybe it increases performance, lower latency. So bundle those arguments together. Sadly, most people, if you come to them and say, hey, we're going to make this 5% greener, they're like, okay, you also have to deliver other values. So bundle it together with other things. And then what I want, maybe this is I don't know if it's a secret tip or not, but I think there's a lot of goodwill to be had around publicly talking about this. So say you did something, you could see that it decreased your emissions, and you go and talk about it. It can be a positive story. So even if you are being carbon efficient, you're delivering the same value for lesser carbon. That value can still be that you can talk about it externally and say, this is what we did. And your customers will think, hey, what a nice company. I want to buy their stuff because I want to be green too, because consumers want to be green.
Yeah, I mean, a lot of corporate sustainability reports are talking about here's our carbon impact. We're trying to go, carbon neutral, and it's all playing with the numbers. There's ways of manipulating it so that you look good in a report, but it is for that public campaign saying, hey, this is important to us, and we're making strides to reduce our footprint. And it started with, okay, we're just going to make sure the lights are turned off in the building. And then it turns out everyone went home for COVID and they just never turned the lights back on in the building. So they're a big win. But now it is looking at the second and third order effects. We've now put all of our stuff in the cloud. So we have to understand what is the carbon impact of our software running in the cloud as opposed to the data center where it's a little easier to manage and measure.
There is one downside of advertising and talk about what you're doing, although I really like it when people do. It's fantastic when they do. If you go into the ESG area, they are very keen on getting really accurate numbers. The trouble is that a lot of the times it's really quite hard to get accurate numbers at the moment. And therefore that kind of go, well, if I can't get accurate numbers, I'm not even going to start. But there are significant knock-on benefits to being green. Even if you don't have the number, there are things you can do that are kind of proxy measures for being green and are worthwhile in and of themselves. So I often say, well, your hosting bill isn't a perfect proxy metric for carbon emissions, but it's not bad. And it's a really good place to start. The very basic things that you start with to clear up your systems, like turning off stuff that you're not using anymore, has low value, or you're over provisioned, get your right sizing everything. That has an immediate impact on your hosting bill. And I always think that in terms of green, if it isn't at least a double win, it's probably not green. So to start with, the double win is you cut your cost. And then as you get a bit more sophisticated, the way that you then cut your carbon again is usually by using more modern resilience techniques like auto-scaling. Well, that has a triple win there. You cut your hosting costs, you cut your carbon emissions, but most importantly, you get a more resilient system because auto-scaling is a lot more resilient than having a cold or even a hot backup somewhere. So again, you're looking at that double win. And if you don't have the double win, ironically, it's probably not green because it won't scale.
You mentioned there were several different proxies. So the bill is the one. What else can we look at for, some sort of measure to say, am I green beyond just the bill that I'm getting?
Well, I do quite like the most obvious proxy other than the bill. The bill is the nice, easy one to start with. The more sophisticated one is performance. Because as we said, each CPU cycle costs you time and it costs you money and it costs you carbon emissions. So basically, if you can improve the performance of your system, as Sara said, if you could just reduce those niggles, all those performance bugs that you kind of always meant to fix, but you never really got around to fix those performance bugs, you go faster and you reduce less carbon into the atmosphere.
The reason why that works is because you're then cramming more work into your CPU in shorter amount of time, meaning you might not need 2 instances or 3 instances. You can reduce down. Now, if you're in the cloud, that's great because someone else can use that hardware. If you're on-prem, then you might say, oh, but I already have all those machines. However, you want to think forward as well, like into the future in terms of capacity planning. You may not need to buy additional servers if you're using the ones you have more frugally. So you might be able to maybe even turn someone off and save them for a bit. So that's why performance is a good metric. Don't just speed things up for the sake of it. You speed things up so that you can reduce your footprint.
I like that you brought up the on-prem versus in the cloud, because I think there's some mindset that, I have to go to the cloud or we can't be green. And you can apply these same techniques in your own data center. It's the same thing. Like you can run microservices yourself. You can host all those things if you need to on your own hardware. Plenty of companies do. And that's the idea that I shifted from. You said you don't want to just do the straight lift and shift. That's inefficient for all the reasons. But you also have to start thinking about, how do I design my system so that it can auto scale up and down, even though that's on my hardware. And when it scales down, can something else run in its place so that that machine that's still sitting there running is not completely useless? It's actually producing some value.
Well, or ideally it gets turned off. The ideal is you just turn the stuff off when you're not using it. That is absolutely the dream. In fact, from what Sara said, obviously we're completely in agreement on this. The way I quite like to say it is start operate with operational efficiency and use cost as your way of measuring that. If you could just run fewer machines, then it's reflected in your energy bill if you're on-prem, or your hosting bill if you're in the cloud, because you've right-sized or you've got rid of systems that are not doing anything. And then only after you've done that do you think about performance and effectively code level tuning. Because if you start doing the code level tuning before you've got really good at the operations, then you just end up with a whole load of machines that are only partially utilized. So you've got to start with ops first. So cost is your first proxy. Performance is only a later proxy.
Yeah, do it in the right order. And I think also maybe something that, if you're not that into green software, maybe haven't heard about, and the reason why we say turn things off is because there's something called energy proportionality about servers. And this was, I believe, first introduced in 2007 by 2 Google engineers who wrote this amazing paper, which I recommend people to read. But basically, when you turn a server on, it consumes a baseline of power that's pretty high. In their paper, it's like around 50%. That was an aggregation over, Point is, it's pretty high and it's not doing anything. And then as utilization increases, the curve goes up. But even if you just have an idle machine, you're consuming a big chunk of energy. So you want to be mindful of that and have properly utilized machines or turning them off. And I think their paper originally was to propose we do fully energy proportional hardware so that the curve starts at 0 and then increases with utilization. I haven't seen any servers that can do that yet. That would be amazing. So looking forward to it. It's very much a research area still, but we're not there yet. So idle servers consume lots of energy.
Again, that's something you can do on-prem, is that you can set yourself a target of saying, average across my entire estate, have I got between 50 and 80% CPU utilization? So 80%, above 80% is problematic because you end up with all kinds of other downsides of having all machines that are a little bit highly utilized. But on average, if you can achieve 50% across your estate, then that's a great target.
Yeah, I think some people will look at a metric and like, oh, my CPU is sitting there like 5 or 10%. I'm doing great. And that's a mindset you have to get out of. Like, oh, if that's the only thing that machine's doing, that's over provisioned.
Absolutely.
You can get the same performance with that running at 50%. You're not introducing latency. You're not introducing any other concerns. It's just more of the smaller size CPU. And like you said, someone else can use that CPU for something else if you're in the cloud.
Yes, indeed. But on-prem too, it just requires a little bit of thought.
Right.
Yeah. I mean, you can definitely build the most sustainable data center ever yourself. There is no secret to the cloud. It's just, it takes a lot of engineering power.
Well, there is one magic secret to the cloud, which you can do on-prem, but not very many businesses have the range of workloads to achieve it, which is multi-tenancy. So the secret sauce of the cloud is that they've got such a mixture of tenants and they all have different demand profiles. And they're very good at making sure that you're sharing a machine with people who have different demand profiles. So maybe it's different other side of the world. So they're busy during the day and then you've got a different time of day. It's like, so basically they're saying, well, how do we align these demand profiles so that we never have a quiet machine and we never have an overloaded machine? So some companies can do that. The most famous is probably Google. They're one of the reasons why they're very ahead on all of this stuff. And a lot of the interesting thinking in this area came from Google, was because from the get-go, from a very early stage, they were effectively their own multi-tenant. And they did quite a lot of work to become even more their own multi-tenant. And the classic is YouTube video. When they bought YouTube, that suddenly made them an excellent multi-tenant because YouTube has a very, very CPU intensive workload associated with it, which is video transcoding and encoding. And they were always very careful. So right from the start, there's no SLA on that. They'll say, could be done 5 minutes, could be done in 5 hours, could be done tomorrow. Just we'll let you know when it's done. So that gives them something they can move around in time to make sure they get really high utilization on their machines. So excellent example of finding something that may effectively could be used to make themselves their own multi-tenant. So one thing that any enterprise can do is if you can find that CPU intensive task that you can, if you're in the cloud, stick it in a spot instance. If you're on-prem, you're going to have to orchestrate that yourself in some way. Kubernetes does have a spot instance tool associated with it, so you can do it on-prem. But yes, the secret sauce of the cloud is multi-tenancy. Hard to manage otherwise.
Also, Google has been doing their YouTube processing, the media processing, have been carbon aware since 2021, I believe, which is another fun fact about them.
But that's the thing. They have the incentive because they are at such a scale. Yes, there's the carbon benefit. There's also the cost benefit for them because I'm not buying the GCP instance. Google is paying for that. Even if it's one division of Google is paying another division of Google, like, please host this software for me. There's still a lot of costs. And so those big things that add up to multi-comma numbers, we can do this and we can get cheaper energy. Like you said, if we can run this on solar somewhere else later, then let's just do that. It also gives you the ability, I guess, to follow the sun. Like we talk about that for software support, that we have people all around the globe so that we can support our users. But when you say, I want to move this software, It's not, I'm always going to move it to Sweden or Norway or somewhere. I'm going to move it to wherever it might make sense right now. So I don't have to necessarily wait 18 hours. I could just pick a different place potentially.
You can do, but I have to say we're more keen on a shift in time than a shift in space. It depends. If it's something with a low amount of data associated with it, then shift it in place. There's no problem. You're not moving a great deal of data. But if you are moving a great deal of data, you're often better off coming up with some cunning wheeze, which will enable you to just do the work either beforehand. Pre-caching is a big thing. You do things in advance, like a CDN does a whole load of work in advance, or do it later. But that just involves architects coming up with some clever plans for how they can do things early or late.
Because we do worry about network cost, like we're spending carbon in the networks. Because, spoiler alert, networks consume a lot of energy. They have a lot of equipment that eats a lot of electricity. So sending data on the internet for long distances, if it's a lot of data, we're spending carbon. So then we're worried that is actually counterweighting to the benefit you had of moving it to a green time zone. Because of that, again, you can't necessarily easily see where your network is consuming electricity. That's just harder the way the internet works. Also, there's of course a lot of, especially in Europe, I want to say, legal rules around where you can move data, and you have to be mindful of those things as well.
So you brought up a couple different things, the two of you, in the last minute. So Sara was talking about networks and said architects have to come up with these clever solutions. So the InfoQ audience is engineers, architects, DevOps, SREs. We have all these different personas. And so think about those different people and the different viewpoints. How would a software engineer think about changing their job to be more green versus an architect versus, say, a DevOps engineer or a platform engineer that's responsible for deploying all this stuff and setting things up?
I would say that you start with the platform. So the platform engineers talk to the software engineers, talk to the architects, and come up with a platform that's going to work well for what they do. And it has to be a platform that, in the long run, the platform creators, the people who support that platform, are committed to it being a platform for the future, a platform that will be able to run on top of renewable power. So just for example, Kubernetes are working on all of this, but the clouds, there are some things that the clouds do that are green platforms, and they talk about as green platforms, and some things that they kind of are clearly not, and therefore they don't really mention green associated with them. So this is, again, where Sara was saying you have to use your consumer power. You have to ask. You have to say, is that a green platform? Is that a platform that's that's just going to be able to carry me all the way through to 24/7 carbon-free electricity in 2030 or 2035? Or is it not? Is it going to be a dead end for me when I'm going to have to re-platform at some later point? So the first thing is make sure you choose the right platform. And then after that, and this is where the techies come in, where the architects come in, it's using that platform as it was intended to be used. So using that platform really well, which means reading all the docs, learning how to do it, and grasping that platform. It's worth for a platform engineer now, you need to step back and say, is this a green platform? And if it's not, what's my plan for moving to one?
And one place to start could be all three major cloud providers have their own well-architected frameworks, and they all have a sustainability section within that. So that can be a good place to get going. I think all three of them could be a bit more comprehensive, but I think they're a very good start. So no matter who you use, that's a good starting point.
And it's well worth saying that have a look at the well-architected framework sustainability section for all of them, and that will give you information. You can ask your account manager, but quite often they'll tell you stuff that's not so useful because they don't always know. You can ask, a lot of them have a sustainability architectural expert, and you can ask to speak to them and they will know what the green platforms are. But if you just say, is this a green platform? Quite often they will say, this is already a green platform because we offset everything. So this is a big thing at the moment. A lot of them are saying, we offset everything. So we'll pay somebody else to, but that is not enough. Carbon neutral is not carbon zero. It's not getting us there. It's It's the goal of 10 years ago. And all too often, when you ask a hyperscaler these days, is it a green platform? They'll say yes, because we offset everything. And that is not sufficient.
Yeah, I still hear companies talking about we're going carbon neutral or we made it to carbon neutral. It's like, okay, and next. So the goal after that is carbon zero. And that's for the data centers, that's for software, that's for hopefully every company eventually. It might not be tomorrow, but it's a goal, right? You can have these long-term goals.
Yeah, indeed. Carbon neutral, if you're not already there, you are quite behind the times, but it's the first step.
Let's go to something that's not carbon neutral. Machine learning, AI, LLMs, they get a lot of press of power consumption, data center consumption, CPU. It's like the new Bitcoin mining. I'm going to go and train an LLM. Some of these numbers are hard to come by. I don't know if you guys have looked into how much it is. And there's two aspects, right? There's the training of the LLMs, the AI models, and then there's hosting them, which can be less, but if they get used inappropriately, like any software, they can also have significant consumption sides to that. So where are we at with that? What does it look like? Do you have a sense of the impact? And then what do we do about it?
So I can talk to where we are and where I think we're likely to be. Sara is the expert in techniques to reduce the carbon associated with creating models or running inference. But from my perspective, yes, there is a great deal of power being used by LLMs at the moment. Do I think that's a problem? Not actually. I'm going to be controversial and say, no, not really, because it's very much at the beginning. And it feels to me like it's a gold rush and all, hardware is being used like crazy and nobody's waiting for the sun to shine. Everybody's running everything all the time, that kind of stuff. But fundamentally, AI, both training and inference, has the potential to be something that could be shifted to when and where the sun is shining or the wind is blowing. There's loads of potential asynchronicity about those loads. They're very CPU intensive. And right now they tend to be urgent, but that is because we really at this stage terrible at AI. We don't know how to do it. We don't know how to operate it. Inference, for example, is often described as something that has to run instantly. That maybe the training you could do in advance, but inference is instant. But we've got tons of experience of things that need to be done instantly that are not done instantly on the internet, for example. I mentioned CDNs earlier, content delivery networks. When you want to watch Game of Thrones, it's a bit of an old school reference now, but if you want, in the old day, when you want to watch Game of Thrones, you say, I want to watch Game of Thrones now. It has to be delivered to me. And back in the very old days, we would have said, oh no, it has to be delivered from the US to the UK now, instantly. That's going to be impossible. Oh my goodness me, it's going to overload the internet and everything's going to collapse. But we learned that wasn't the way we needed to do things. What we would do is we would say, well, everybody wants to watch Game of Thrones. So we move it to the UK overnight and we sit it on a CD not very far away from where you live. And it seems like getting it from the US, but you're actually getting it from 100 yards away. And it's very quick. And it's kind of a magic trick. You do things in advance. It's a form of pre-caching because humans are not that different. They want to watch the same shows and they want to ask the same questions of AI as well. So there's tons of opportunity for us to get good at caching on inference, I think. And I think that's where we'll go. But yes, so at the moment, it's horrendous. But I don't think it's as bad as Bitcoin. Well, it's similar to Bitcoin at the moment in many ways, but it's not innately as bad as Bitcoin. Bitcoin is purely about using power. And this is actually about achieving a result. And if you can achieve that result using less power, we will. Sara, it's actually your area rather than mine.
Yeah, we seem to be talking about this a lot lately. I guess everyone in our industry is talking a lot about it lately. I think one of the good things is when I started my journey into how do we build greener software? A lot of the research that was out there was actually AI related. And specifically on the training side, there are very smart people who've been thinking about this for a long time, which is good. And I think especially on the training, because if you go a few years back, that was maybe the bigger source of emission, or at least it was a bit easier to do research on, perhaps. So there is a bias there. So there are tons of things we can do. Like we can time shift, obviously. There are a bunch of methods for making the model smaller. Like there are tons of research paper that describes techniques on how you can achieve that. You can also think about, on the inference side, how you deploy it. If you use things like federated learning, are you utilizing your edge networks with moving data and the models closer to your users? And all these things that we had talked about before, like how do you do the operational efficiency for AI workloads is not super foreign to, like it's this, like you use the same tools, like maybe you screw them in slightly different ways, but it's very similar. So we're in good hands there. I think we will learn over time to apply these to the workloads, because, and this is something Anne and I have talked about before, we need to make it green. There isn't an option where we say use AI or be green, because where we are at this point in time, that's not a fair choice. We need to make AI green. Like that's the thing. And we will definitely, as an industry, get there, I believe.
Yeah, I agree. I mean, it's amazing how often we run across people going, oh, well, yes, the only green AI is no AI. You turn the AI off. Well, there's only one thing we can be really, really certain of in the tech industry, which is that AI is coming and the energy transition is coming. Both of those things need to be done at once. We cannot pick and choose there.
Yeah. And I think also what's interesting, because now we have said AI a lot, but I think what we all have meant is generative AI and LLMs, right? And it's really only one branch of AI. I think we're going to see more approach and that they will maybe have completely different characteristics that will, and I'm curious to see how that goes. But I think specifically with large language models, we're seeing the rise of small language models, and they're often outperform. So a specialized small language model often outperforms a more general large language model on specific tasks they're trained for, which is obvious when you think about it. And so I think we're also going to see more of that. And they also have the benefit that they can be closer to you, maybe even on your device, because they're small. It's right there in the name.
Yeah, one of the techniques that is often used for getting the large language model to be better is to throw a larger prompt at it. And it turns out if you have a small language model that's basically trained on what you're prompting with every time, the analogy I liked was you can send someone to med school or whatever, and they've spent decades going to school, or somebody wants to be a CPA and be an accountant. They only need to go to a 2-year program and they learn how to be an accountant. I need the accounting LLM for my accounting software. I don't need to ask it all about Taylor Swift. If it knows about Taylor Swift, it's not actually a good language model for me to have in my software. And now it's this larger thing that I'm not fully utilizing, just like the larger server that I'm not fully utilizing. So I like the idea of get something smaller and you're going to get better benefits of it. So it kind of plays into your, there's these co-benefits. So smaller, faster AI is greener software. So I have to call out, there was a talk at QCon San Francisco just last month about GitHub Copilot, and it talked about those same ideas that it was specifically talking about how to make the requests very quick, because they need to act like this is software running on your machine in your IDE. And to make that happen, it has to be making local network calls. So they have it calling the local Azure instance that has the local AI model or LLM, because they can't afford to go across the pond to look it up, because it would just take too long and then the software wouldn't work. So all those things are being discovered as we're finding these large use cases for things like GitHub Copilot. I do want to give you a chance to talk about the Green Software Maturity Matrix. I mentioned a little bit in your bio, and so tell us, what is that?
Well, actually, that harks back to something we talked about earlier today in the podcast, that it's very, very complicated. This is something that Sarah and Sara and I really hit writing the book. And we knew from going out and talking at conferences and things about this stuff. There's lots of different things that you can do to be green, and there's lots of different ways you can approach it. And there are some ways to approach it that are just vastly more successful than others. And we spent quite a lot of time thinking in the book about how we could communicate the process that you should use. So don't try and leap to the end. Don't try and be Google in one leap, because you'll fail and then it won't be green. It might be, if you set your goals too high, your bar too high, you'll fail to achieve it. And then you'll go, well, it's impossible to be green. And that's not the case. You just needed to do it in a more regulated way. So we put a maturity matrix is a project. It's quite an old-fashioned project management techniques that basically says, well, what does good look like? But also, more importantly, it says, but you're not going to get there in one go. You do need to get there in a maturity matrix. Rather arbitrarily chooses 5 steps to get there. And if you do it through those 5 steps, you will almost certainly get there. If you don't do it through those 5 steps, if you try and skip a step, then you will fail miserably. So the maturity matrix was basically step 1 is just want to do it at all. Step 2 is basic operational efficiency. So turning off things that are not in use, right sizing. Step 3 is, high-end operational efficiency. This is like modern operational techniques. So auto-scaling, using the right services properly. And only at 4 and 5 of the matrix do you start doing things like rewriting things in Rust. And ideally, most enterprises would never have to achieve 4 or 5 because they will adopt a platform at level 3 that will do 4 and 5 for them. So that's kind of like the idea. It should be, if you follow it, a very successful way to get modern systems that achieve 24/7 carbon-free electricity or can run on 24/7 carbon-free electricity by stopping you from trying too hard.
And it also, I think, nicely separates the vast area of sustainability into swim lanes. So depending on your role, you can start with the swim lane that feels the most natural to you. If you're a product manager, you start in the product. You don't have to start in one of the other ones. And you sort of go from there. And I think that's also a good mental model for people, because sometimes when something is new, it can be a bit overwhelming, and spreading it out, not just as 5 layers, but also 9 different categories, really shows that, okay, you can start with one thing. Just do this cell, and then you can sort of expand from there. Just pick any cell in the first level and just start there and sort of take it step by step. I always these days start my conference talks with that slide, because I think it's a good way to kind of set the expectation. Like, this area is big. Today we're going to focus on this, because I can't reasonably talk about everything about sustainability and IT in 1 hour or how long we have. So we're going to focus on this. Just know there's like more stuff. It also helps prevent the question, what if I just rewrite everything in Rust, like Anne said? Because somehow we always get asked that. Somehow I can never escape that question.
Everybody wants to rewrite the systems in Rust or C. Why?
The fan base is massive. Kudos to the Rust folks, because like you have some hardcore fans out there.
We just had a Rust track at QCon, so yeah, it's popular. So we're this has been a great conversation. I think we're running a little long. I want to give you guys a minute to give a little plug for the Building Green Software Book Club. I attended the first meeting last month, I think it was. What is the book club, and how can people find out more about it?
So we're aiming to do once a month, one chapter of the book. We have done one. So far, we're on track. I think there will be maybe a bit of a break now over the holidays, but we'll come back on track. You can find on our LinkedIn pages. We have a link out. You can sign up there. It's on Zoom. It's very casual. Like, we chat. You can ask us questions. As you might have noticed in this podcast, we're happy to talk about stuff. So even if there are no questions, we'll talk anyway. People enjoyed it last time. I enjoyed it. It was very cozy. It was very nice to see people face to face, virtually. Yeah.
Well, I'll be sure to add links to the book, to the maturity matrix, to the book club in the show notes. Anne and Sara, thanks again for joining me today.
Thank you again for having us. It was lovely.
It was really awesome. Thank you for having us.
And listeners, we hope you'll join us again soon for another episode of the InfoQ podcast.